right, so let's take a look at Unit 4, Lesson 8, Unknown Exponents. All right, so 8.1, a bunch of x's. Solve each equation, be prepared to explain your reasoning. So we have, for number 1, we have x divided by 3 equals 12. And so if we want to get x by itself, we undo division by multiplying. So whatever we do to one side, we have to do to the other. So x equals 36 because we're multiplying 3 on both sides. All right, number 2, we have 3 times x squared equals 12. So first we're going to divide both sides by 3 because that undoes the multiplication. So then we have x squared equals 4. And then we can take the square root of both sides. Remember that whenever we take the square root of both sides, we need that plus or minus. And so we have x equals positive and negative 2. Let's take a look at number 3. X cubed equals 12. So we undo a cube by taking the cube root of both sides. Now, when you have a cube root, you don't have to take the square root of both sides. So x is equal to the cube root of 12, and that does not really simplify. You could plug that into the calculator and give an approximation if you want to. All right, let's take a look at number 4. The cube root of x is 12. So this one's a little bit different than the previous one. To undo a cube root, you take the cube of both sides, or you cube both sides. And so when we cube both sides, we have x equals 12 to the third. And again, you could plug that into the calculator. You get a fairly large number, or you can leave it that way. For number 5, we have the square root of 3x. That is all under the radical, and that equals 12. So to undo the square root, we square it. And again, we can do that because the 3x is all under that radical. If only part of it was, then we would have to do some division first, and then we could square both sides. All right, so 3x equals 12 squared. And we can simplify that a little bit more. 12 squared is 144. So 3x equals 144. And then we can divide both sides by 3 to undo that multiplication. So then x is going to be 48. Because 144 divided by 3 is 148. I'm sorry, is 48. Sorry. And then for number 6, this one is different from number 4. A lot of people get mixed up on this. They think they can just divide by 3 and get the answer, but the x is in the denominator. We have 3 over, or 3 divided by x equals 12. So you have to be careful with this one. So the first thing I would do is get rid of my fraction by multiplying both sides by x. So then I get 3 equals 12x, just so that way I don't have any fractions anymore. You have to bring that variable up from the denominator before you can do anything else. And then we're going to divide both sides by 12. And so x is 1/4 because 3/4 simplifies to, 3/12 simplifies to 1/4. All right, let's take a look at 8.2, a tessellated trapezoid. Here is a pattern showing a trapezoid being successively decomposed into 4 similar trapezoids, similar meaning that they are all the same shape, but not the same size necessarily as the original or necessarily as each other. So at each step, there are 4. Each of the trapezoids is divided into 4 similar trapezoids. So for step 1, we have 1 trapezoid. For step 1, we have 4 trapezoids. And for step 2, we have 16. Okay? All right, so for number 1, if n is the step number, so this is n, these are your n, how many of the smallest trapezoids are there when n is 4? So we can actually set up an equation for this because if you notice, we do have our initial value. And what is the pattern here? We are multiplying by 4 every time. So we have a constant ratio of 4. So we know that our function of n is equal to that initial value, which is 1, times our constant ratio, which is 4, to the power of n, which is our step number. All right, so if we want to figure out what n is, what the number of trapezoids is when n is 4, then we're just going to plug in f of 4. And so we have 1 times 4 to the 4th, which is equal to 256. All right, what about when n is 10? So let's take a look at that. F of 10, so now we have 1 times 4 to the 10th. So 4 to the 10th is a really large number, so we're just going to leave it like that. All right, let's take a look at the next part. At a certain step, there are 262,144 smallest trapezoids. Write an equation to represent the relationship between n and the number of trapezoids in that step. So we already knew that we had f of n was equal to 1 times 4 to the n. So we know that 262,144 is equal to 4 to the n. All right, so we could find the value of that step number by somehow undoing that power of n. So like one thing that you could do is just multiply 4 times itself until you get to 262,144. That might take a while, but that is possible. That is one way to figure it out. And we are going to soon talk about an easier way to figure that out. All right, let's take a look at the next part. 8.3, successive splitting. So in a lab, a colony of 100 bacteria is placed on a petri dish. The population triples every hour. How would you estimate or find the population of bacteria in 4 hours, 90 minutes, half an hour? All right, so let's set up our equation. All right, so we have, let's say f of n. If you want to use a different variable, that's fine too. Our starting value is 100 bacteria, and the population is tripling every hour, so we're multiplying by 3 to the power of n. And actually, you know what? Let's make that h. Nah, we'll make it t for time. All right, so we'll make it f of t. Okay, and in this case, t is in hours. All right, so for number 1, that's pretty easy. We're just plugging in 4, so f of 4 hours, is equal to 100 times 3 to the 4th. And so that's how we would estimate or find that population. 90 minutes, we would first want to convert that to hours. So 90 minutes is equal to 1.5 hours. So then we would do f of 1.5 equals 100 times 3 to the 1.5. And then for half an hour, again, we would do f of 0.5 or 0.5. I prefer to do 0.5. Equals 100 times 3 to the 0.5. I think those are the easiest ways that we could find those populations. All right, so let's take a look at part 2. How would you estimate or find the number of hours it would take the population to grow to 1,000? So in this case, we're not plugging in 1,000. 1,000 is our f of t. So that equals 100 times 3 to some t value. So we could divide both sides by 100, and we get 10, right? Divide both sides by 100. And so we get 10 equals 3 to the t. So then you could kind of look at, okay, well, how many times can I multiply 3 to get 10? And kind of figure out from there, you know, what decimal might be close to that. Or you could graph it and see, you know, where that might lie on the graph. That's another way of doing that. All All right, and then for B, it says double the initial population. Well, remember that the initial population was 200. And so we could say, well, 200 is equal to 100 times 3 to the t. So again, you could divide both sides by 100 and then kind of figure out, well, that would end up giving you 2. So you had 2 equals 3 to the t, and then kind of figure out, well, what value of t is going to give you something pretty close to 2. And you know it's not going to be 1. It's got to be less than 1. And it's not going to be 1/2 because the square root of 3 is greater than 2, so, or is less than 2. And so it's going to be somewhere in between 1/2 and 1. You could, again, also look at the graph to see what that would be. All right, so again, we're looking at how can we solve for our exponent value? So in 8.4, missing values, we're going to complete these tables using some of these methods that we were talking about. And so we're looking at figuring out, okay, well, how can we find these missing values? So in number 1, we want to figure out, it might be easiest to find the starting value. And so if the first, well, okay, so here's our initial value is going to be wherever x is 0. And they did give us that we're looking at 2 to the x. So 2 to the 0 is 1, right? And let's go through the positives first. So 2 to the 1/2, that's the same thing as the square root of 2. 2 to the first is 2. Now we're looking at 2 to what power is going to give us 4, so that's going to be 2 to the second. 2 to what power is going to give us 16? Well, that's going to be 2 to the 4th. 2 to the 5th is going to give us 32. And then 2 to what power is going to give us 256? I know I can't do that in my head, so let's break out a calculator to help us here. And there's a couple ways you could do it. You could graph this if you wanted to. I'm just going to use the scientific calculator, though. All right, so we could do, all right, well, we know 2 to the 5th is 32. So let's see what 2 to the 6th is. Okay, well, it's not 64. So then we could take that answer and multiply by another 2. That gives us 128. So that was 2 to the 7th. Let's take that answer and multiply by another 2. Oh, 256. So that was 6, 7, 8. So it was 2 to the 8th power. All right, and then we could do another 2. That's not it. So that was 9. Another one is 10. So that was 2 to the 10th. All right, so then we can look at an x value of what is going to give us 1/4. 2 to what power? So 2 to the negative 2 is going to give us 1 over 2 squared, which is 1 over 4. And then the 32, well, we already saw that 2 to the 5th is 32. So if we have a negative 5, that's going to be 1 over 32. All right, let's take a look at the last one. So we have x and we have 5 to the x, right? So if we plug in 1, we're going to get 5. And 5 to the 0 gives us 1. So there's our initial value. 5 to the negative 1 gives us 1/5 because that turns it into a fraction. 5 to the negative second gives us 1 over 5 to the second, or 5 squared, which is 1 over 25. So that's a negative 2. Let's see, 5 to the 1/3, that's going to give us the cube root of 5. 5 to the 1/2 is going to give us the square root of 5. 5 squared is 25. So if we multiply by another 5, we get 125. So that one's 3. And then if you don't know, you can use a calculator. So we have 5 to the 3rd gave us 125. So then let's multiply by another 5. That's 625. Oh, that's what we want. So 5 to the 4th is 625. And let's multiply by another one. And there's 3,125. So that one is 5. So you can use a table to find some of the missing values if you don't know what your exponent is. But we're also going to talk about another way to figure that out. And then remember that you have a summary if you want to read through that.